Hello,
Yes, ma'am.
I'm audible, na?
Yes, ma'am.
Okay, so good morning all. We will start the today's lecture. So what we have completed in the last lecture is we have taken one program related to the timer and uh, explain the complete program stepwise. So hope you understood the program timer programming, and now you could able to write the program on your own. Okay, so that is the main intention. Again, I am asking ki if you are having any doubt related to that, you can ask me any doubt. So I am sharing the code what we have explained, what we have completed in the last lecture. So why because it's all codes are same, structure of timer coding is same, but only the statement, according to the statement, what will be the change? The change is the initial value to be loaded in the timer register, that will going to change. Means what you want on period and off period, according to that the initial value calculation will change, but the number of instructions, the flow of the program, and the structure of the program remains same. So hope you understood this. And in this already I told you we have to do the calculations. In this calculation part, the two parameters are there. If the initial value loaded in the timer register is already given, right now in the previous program it is given as FFF2. FFF2 is the initial value loaded in the timer register. If it is given, now you should able to calculate how much delay is generated by this value. This is one task. Means according to the given value, you have to calculate how much delay is generated by that value. And second task is, if user want to generate a prescribed delay 5 millisecond, 10 millisecond, 20 millisecond, what value, initial value is to be loaded in the timer register. Are you getting these two parts in the timer? What are the two parts? First part is, if the value is given and that value is loaded in the timer register TL and TH. Okay, so how user come to know ki how much delay is generated by that value? So there is a procedure to calculate by the any value loaded in the timer register. If you know, you can able to calculate the delay generated by that value. And other part is, if user want ki I want to generate a delay of 10 millisecond, so as to generate the 10 millisecond delay, what initial value is to be loaded in the timer register, that user has to calculate. So these are the two tasks in the timer programming. Initially we have just completed the theoretical part, the register, organization of the register, three basic registers we have studied in the timer, and we have studied a basic program of timer. Okay, now the calculation part first of all we will finish up, and then we will go for the simulation. Now see all of you, concentrate on the screen, whether the screen is visible to all. Hello.
Yes, ma'am.
Okay,
Yes, ma'am.
concentrate on the screen. Afterwards, you have to write down these steps, because these are the calculation. So what I told, I have given you the idea related to the two parts. Key two parts are there in the timer calculation. So first part is, if the initial value loaded is given, that is FFF2, the same example I have taken. So how to calculate the delay generation by that value? This is the first part. Now see what is given. Calculate the amount of delay in the delay subroutine generated by the timer. Assume the crystal frequency is 11.0592 megahertz. So from that you should come to know is the crystal is on chip, that is the internal crystal frequency, internal frequency. So obviously the operation is delay generation. By that way also you can cross check. So they have given the frequency. Now just listen carefully, what are the steps to calculate the delay generated by the given value. Now first of all, already we have seen the hardware diagram. The timer works with the frequency of 1/12 of the crystal frequency. So that's why in the hardware diagram you have seen key crystal oscillator divided by 12, and that is given to the TL and TH. Okay, so that's why this is very important part. The timer works with the clock frequency 1/12 of the crystal frequency. So they are divided in the 12 part. Okay, and why it is so? It is already designed in 8051 microcontroller. So that's why we have to take this. Okay, now if it is so, then we have to calculate the total frequency, that is 11.0592 megahertz divided by 12. So this is my frequency, because always the 8051 timer works with the clock frequency 1/12 of the crystal frequency. The crystal frequency is given as 11.0592. So 11.0592 megahertz divided by 12, that is equal to 921.6 kilohertz as a timer frequency. Means what is the actual frequency for delay calculation for the timer circuitry is 921.6 kilohertz. Okay, so now if you got the frequency value, can you able to calculate the time period? Because we are more interested in the time. Okay, so the simple logic, as a result, because of this frequency, each clock has a period of this. How? Because all of you know T is equal to 1 by F. Right now, as per the requirement, we have calculated the timer frequency as 921.6 kilohertz. So I can able to calculate the time period T is equal to 1 by F. Right now my F is 921.6 kilohertz. So the time period of each pulse, each clock period is 1.085 microsecond. Now just listen carefully. If I know the period of one pulse, one clock, then how many number of counts you have into this, that will be the delay generation. Are you getting? If you want, if you know the clock period of a single pulse, single clock, that is 1.085 microsecond of the timer, and if the timer counts n number of counts, so n into this will be the total time delay generation. So this is the simple way to calculate the delay generated by the given value. Okay. So this is related to the timer circuitry. This is the standard formula. Okay. Now how to calculate the actual? Already we have seen in the timer programming ki my initial value loaded is FFF2. So if you know the initial value loaded as FFF2, how you come to know ki by this value how much delay is generated by this timer programming? So that we will see. So see here again the same value they have taken. So these are the two formulas you have to follow, which is highlighted in the blue color. Okay, so if you know the value in hex, that hex value, the whatever is the hex value, that is subtracted from FFFF, that is 16-bit maximum value. Maximum value is FFFF minus YYXX is the value which is to be given. Which value? Which is loaded in the timer register, and we have to calculate ki by that value how much delay is generated by the timer. So this value is called as YYXX, and why they have mentioned likewise YYXX? XX will be the lower byte, YY will be the higher byte, that's why. Okay, plus 1 bracket close. So these are, then you will get the number of counts. Are you getting the formula? So maximum value minus that initial value plus 1, that will be equal to the number of counts into 1.085 microsecond. So right now I explained YYXX is TH and TL, initial values respectively, that is loaded in the timer register. Okay, now one can ask why this x one is required, madam. What is the intention of 1? Because the initial value loaded, and what is the maximum value? If you subtract that, we can get the number of counts of that timer. But here when you get the calculations in the hexadecimal, then you have to write a value as 1. because it is taking as f, that is the hex number. But in decimal, no need to take 1, that is plus 1. See, 65536 f, its decimal is 65536. Actually this becomes 65535, but here it is in the formula itself they have taken 65536. Here as they are hex numbers, so we have to add 1 in that. Okay, so see, 65536 minus n. So again, n is nothing but your xx. That is the initial value loaded in the timer register into 1.085 microsecond. So what is these two? This first is, if you want to calculate the delay generation, first of all in hex. If you want in decimal, you have to follow this formula. If you want in hex, you have to follow this formula. No doubt after this in hex calculation, whatever the value you are getting, again you have to calculate in decimal and you will get the final calculation. So these two formulas are, first is calculation in hex and second is calculation in decimal. And you have to follow the formula for hex, that is f 4 times minus yxx plus 1 into 1.085 microsecond. And in decimal, 65536 minus 4 times n into 1.085 microsecond. So 4 times n, just they have given the naming convention. Nothing different. Again the same value, that is yxx, that is th and tl value. Okay. Now see, what is my value? My value is given as ff2. Then you have to calculate the number of counts. How to calculate the number of counts? The initial value loaded in the timer register I know. I know the maximum count of that timer. So maximum count, that is f minus the initial value loaded, that is to be subtracted as per the formula f minus yxx. So yxx is in our case is ff2. Then it comes 0d. And what is the d value? In hexadecimal, d means in decimal it is 13. So you have to add 1 in that. That's why I have taken 14. So 14 into 1.085 microsecond. So 15.19 microsecond for the half pulse. Means for the entire period, obviously, means total time period 30.38 microsecond. So the delay generated by this value given is 30.38 microsecond as a delay generation by the timer. In this way, if you have provided any value, that is the initial value in a hexadecimal or in a decimal, you should able to calculate the delay generated by that particular value. So first of all, note down these formulas in hex and in decimal. Yes, all of you note down these formulas in the notebook which are highlighted in the blue portion, blue color. And once you note down that, you can do the calculations or you can write down the steps as per your convenience written in the solution, because these are very, very important steps. So see, in the timer, two types of questions will be asked. The initial value is loaded, the initial value loaded in the timer register is provided. You should able to calculate the delay. Otherwise, if in this problem statement they have mentioned so as to generate a delay, x amount of delay, how much initial value is to be loaded in the timer register. That's it. Two tasks are there. So first of all, complete this. Everyone should note down this in your notebook. The formulas are important. Everything is written, everything is in front of you. No need to write in detail the wordings. Already you have the soft copy. At least you note down these two formulas. I will give you the number and tell me the value or delay generation by that value. And then we will take the questions if you have any. Yes, note down the formula. Chinmay Patil. Hello. Chinmay Patil. Harshal Bhosle. Hello. Kunal Gujar. Prashant Goze. Hello. Nobody is there. Sanket Chauhan.
Yes, ma'am.
Have you note down the formulas in your notebook?
Yes, ma'am.
Show it to me. For a while, just switch on your video or camera.
Ma'am, actually, I'm on desktop. That doesn't have camera.
म्हणजे मोबाईलला नाहीये.
नाही मॅम, कम्प्युटर वरती आहे.
ठीक आहे. आणि हे बाकीचे नाही आहेत का मी आता नाव घेतलेले? हर्षल भोसले, कुणाल, so completed. Have you note down the
Yes, ma'am.
formulas in the notebook? Okay.
Yes,
So
ma'am.
see, I will give you the value and just calculate the delay generated by that value. Are you getting what we are doing? We are calculating the delay generation by the initial value loaded in the timer register. For example, directly that value is given to you, X amount of value is given loaded in the timer register. You should able to calculate that how much amount of delay is generated by that value. This is the first step. Okay, so take down the number, just write down the number B8, B8, 3E. So I will just write down that number on the word copy also. B8, 3E. Yes. So this is the number. So B83E is the number, same as that of FFF2 is number. This is the hex number. Now what you have to calculate? How much delay is generated by this value? How much delay is generated by if the initial value loaded in the timer register is B83E, how much delay is generated by this value? You have the formula. So what you have to do is you have to subtract this from FFF minus this plus 1, whatever the value you are getting, into 1.085 microsecond. Are you getting what we have done in the previous task? FFF2, FFFF maximum value minus FFF2. First of all, we have calculated the decimal number, hexadecimal, its corresponding decimal, added 1, so 13 plus 1 becomes 14 into 1.085 microsecond. So same is the calculation for the number. So just do the calculation and tell me the value, how much value you are getting. First of all, these are the calculations in hex. In hex.
Ma'am, the frequency will always remain same. That
Yes, frequency you
1.085.
have, yeah, yes, frequency is standard frequency 11 point, the 1.085 is not the frequency, it is the time period. The frequency is 11.0592 megahertz for 8051. In local author book, in some of the books, they have directly given the standard value as 12 megahertz. But you have to stuck with 11.0592 megahertz. But sometimes in the exam also, if in the statement, problem statement, if they have mentioned the crystal frequency as 12 megahertz, you have to take the 12 megahertz. Are you getting? Sometimes it happens that in the exam, in some exam, in the problem statement, they will mention specifically the crystal frequency is 12 megahertz. So you have to take 12 megahertz. If it is not mentioned, you have to take 11.0592 megahertz. That's it. Okay. So do the calculations. So see, calculations remain same, but what will be the change? But if in the exam, if they have mentioned 12 megahertz frequency, so 12 by 12, so it is 1 kilohertz. Sorry, 1 megahertz, na? So 12 megahertz by 12, so it becomes 1 megahertz. So according to that, you have to calculate 1 by that. Okay. So whatever is the value coming, but most of the time the crystal frequency is 11.0592 megahertz. Some of the cases they may change the frequency, but in the standard book they have given the 11.0592 megahertz frequency. Tell me the calculations. All of you know the how to use the, how to do the hex number system subtraction. Already you are done in the digital or in the first year also. So you can use the calculator also. First of all, tell me this value, only this value, bracket value, and then you have to convert that bracket value into its decimal in the same manner. So first of all, I got the hex number as P. So I have calculated in decimal, it is 13. Then added 1, 14. Because why it is to be calculated in the decimal? Because we have to multiply with 1.085 microsecond. So that's why whatever the hex value you are getting, you have to convert it into the decimal. Okay. So do it. Yes, tell me the value. Sumit Chaudhary. Hello.
Yes, ma'am.
So have you calculated?
No, ma'am. Try.
कॅल्क्युलेट कर. बाकीचे तेजवीर,
Yes, ma'am.
have you calculated the value?
No, ma'am. Ma'am, I'm trying.
हाँ, उसमें क्या ट्राई करना है? बहुत बड़ी बात है क्या? कैलसी पे तो इमीडिएटली आता है. अगर if you are not knowing the calculations on the calci, just learn that. It is important. In the timer you will require this. सुयश कॅल्क्युलेट केला?
नाही मॅम अजून नाही.
करा मग. किती वेळ? बाकी कोणी केलं असेल तर सांगा मला व्हॅल्यू. हा, कोणीतरी टाकली आहे. 47C2 करेक्ट आहे. हरिता 47C2H. ओके, so what you have to do is now, what you have to do is you have to convert that value into the decimal. So I am getting this part as 47C2. Okay, so this is the hexadecimal number. So you have to convert this into the corresponding decimal. So just convert that and tell me the value. Riddhi Mishra, how you are getting 18? Okay, 18.370, correct. So 18.370, 18.9, not 80, 18.370. So what is this value? This value is equivalent of this decimal number, hexadecimal number system. So I have done this part. So 47C2 I am getting. I have converted that into its corresponding decimal. So what next now? 18370 into 1.085 microsecond. So you have to just do the calculations. That's it. It's very easy and simple. So if you just do 2 to 3 program numerical small values, just take on your own and just do the calculations, you will remember the formula also. So how much value you are getting? Tell me the final value. Yes, exactly correct. 19.931 millisecond. Yes, good. Correct. So Harita has given the answer 19.93145 something. You can take up to 2 decimal points also. So this is in short the 19.93 millisecond. Means what is the meaning of this 19.93 millisecond? So if in the timer register, if you load the value as B83E, by loading this value, we can get a delay generation of 19.93 millisecond. Are you getting the meaning of this? The initial value loaded in the timer register. What is the impact of that in the timer delay calculation? Okay, so these are the calculations in hexadecimal. Yes. Now we will do the calculations in decimal. So do that. Already you have written the formula for the same. So any doubt in the hexadecimal calculation? Yes, anyone? Tejasri is also has given the answer for previous calculation. Yes, any doubt regarding this hexadecimal calculation? If you don't have any doubt, you can go for the decimal calculation. So what you have to do is here. So what is the formula? First of all, what you will do in hexadecimal calculation is we have the value as B8 3e, isn't it? So first of all, you have to calculate its corresponding decimal, because we have to subtract this value from decimal. So that's why very first step is, whatever the hex value you have provided, just calculate its corresponding decimal. That's it. Just tell me this value, decimal value of this corresponding hex number. So do it on the calci. Why I had to convert into the decimal? Because the number is provided in the hexadecimal and we are doing the calculations in the decimal. So first of all, whatever is the initial value loaded in the timer register provided, convert that value into the decimal. Yes, correct. 47166. Tanuja has given the answer. So 47166 is the decimal value. Okay, so once I got the decimal of this corresponding hexadecimal value, so I will just write the formula 65536 minus, so see here no need to add 1 because FFF becomes 65535. Already it has taken as 65536. That's why in this formula 1 is not added. So that's why. So just remember the logic. Don't mug up the formula without knowing anything. 47166. So that's it. So do this simple subtraction and tell me the value. Yes, Tejasri has given the answer. Text the answer. That is 18370. Yes, correct. Next. What is the next? Next thing. You have to just multiply. So do it on your own with the proper understanding. Don't copy as it is from the screen. Understand each and every step so that you can able to do any calculations on your own. Yes. What is the task? You should get the same answer. Actually, it is 19.931. Not so. It will come in microsecond. Then just check the answer, Tanuja. You should get the same answer with both the calculations. Only the way of calculation is different. The hexadecimal calculations and decimal calculation, but the final answer should remain the same. That's it. Okay, so again you should get the same value as 19.3145, whatever it may be, and that to be in the millisecond. Yes, everyone is getting the answer? Yes or no? Now you can ask your questions. Any doubt, any confusion, anything which you are not understood, any step, why it is so? Yes, ask me. Are you and all the student understood the all steps related to the delay calculation? Yes, 19.93 milliseconds is the correct answer. So the thing is, by both the methods, obviously you should get the same value, same answer, because my initial value loaded is same. But just I am doing that by two different ways. That's it. Any doubt? Any confusion? Hello? Yes, no doubt. हो पण म्हणत नाहीत, नाही पण म्हणत नाहीत. आपणच बडबड करायची तर काय. See, I have written one number on the screen. So FF1A. So in the next lecture, all of you just do the calculations by the same way and by the both methods, that is the hexadecimal and decimal, how much delay is generated by this value. Okay. So in the next lecture, I will ask the value for the same. Okay. Yes, any doubt, any confusion? अरे बोला काहीतरी. का प्रत्येकाला आवाज देऊनच बोलायचं? प्रत्येकाला इंडिव्हिज्युअली विचारत बसायचं का? ओके, ठीक आहे. काही जण नो टेक्स्ट करतात. Hope you understood the simple and very interesting calculation for the timer, and this is only one part. What is that part is, if the initial value is loaded in the timer register is provided, how to calculate the delay generated by that value. So for that purpose, we have to follow these two formulas, hexadecimal calculations and the decimal calculation. But obviously, by both the methods, one should get the same answer. Okay. The next step is, if the user want to generate a precise delay, precise means 5 millisecond, 10 millisecond, likewise. So what is to be done? I think you don't have the DSP lecture because sir has not shared the link. So we will just finish up this and we will stop for today's lecture. So see, to calculate the values to be loaded into the TL and TH register, look at the following example. So see the statement properly. Right now, what we have done, initial value loaded in the timer register is given. From that, we have calculated how much delay is generated. Now, so as to generate the X amount of delay, what value is to be loaded in TL and TH register, that is to be calculated now. Are you getting the difference between these two tasks? So see, it is written. Obviously, already you have know the crystal frequency is 11.0592 megahertz. You can use the following steps. Now, what are the steps? Whatever is the delay given, the straightforward, you have to just follow this step while calculation also. Divide the desired delay by 1.085 microsecond. So why 1.085 microsecond? Right now we have taken how 1.085 microsecond comes. Each clock pulse has a period of 1.085 microsecond. So whatever is the delay, X amount of delay, suppose X millisecond, that is to be divided by 1.085 microsecond. Okay. You will get some n number after calculation, X amount of delay by 1.085 microsecond. You will get suppose n number. Okay, so you have to subtract that from 65536 minus n. What is n here? From step 1, after division you will get the n value. So here it is written also, where n is the decimal value we got in the step 1. Okay, and the next step is convert the result of step 2. After subtracting this, again you will get some value, you will get some number. So just convert that result, means whatever the number after subtraction you are getting, convert the result of the step 2 in hex, where you will get YYXX is the initial value loaded in the timer register. Means again you will get some value. that value is nothing but YYXX. So XX, as it is a lower byte, that is to be loaded in the TL, and YY is a higher byte, that is to be loaded in the TH register. So the second step is the delay generation. For X amount of delay generation, what is the initial value loaded in the timer register? In earlier step, if the initial value loaded in the timer register is given, how much is the delay generation by that value? So these are the two separate parts, but the related to the same topic, that is timers. Okay. So one example here they have taken. So we will take fast this example and then we will stop. So you can just revise this step. First of all, very simple steps. Whatever is the delay, divide that delay by 1.085 microsecond. Whatever is the value you are getting, subtract that value from 65536. Always, here again there are no two calculations, that is hex and decimal. Only these steps you have to follow. Then you will get some value and convert that value into the hex. And once you get that hex value, just correlate that hex value with YYXX. XX is loaded in TL and YY is loaded in TH. That's it. Okay. Now see, one calculations. Suppose the example is given, they want a 5 millisecond of delay generation. So as per the steps, so just concentrate on the screen. As per the steps, 5 millisecond divided by 1.085 microsecond, you will get that clocks. Then subtract that from 65536, you will get the number. So you will get first of all the decimal number, and then you have to convert into the hexadecimal number. So this number is nothing but your YYXX. So 00 is a lower byte and double E is the higher byte. So TH will consist of EE and TL will consist of 00. So again I will write on the Word doc, that is 5 millisecond divided by 1.085 microsecond. Okay, so you will get some value. So what value you are getting? 4608. So 4608. Okay. So whatever is the value, so this value is nothing but your EM. As per the formula, you have to subtract that from 65536 minus 4608. Just tell me this value, 65536 minus 4608. Tell me the subtraction on the chat box. 65536 minus 4608.
60928.
60928. Correct, na?
28.
So this is decimal. Yes, isn't it? So what you have to do is, you have to load the values on TH and TL register. For that, you require its corresponding hex. So convert the corresponding hex. So convert the corresponding hex value, 60928 decimal, its corresponding hex value. It becomes double E double 0. That's it. Yes? Cross check the value. And here only one type of calculations. So the simple step. Whatever is the delay, I want the delay of 5 milliseconds. So whatever is the delay, X amount of delay, divide that delay by 1.085 microsecond. You will get some value. So that value is to be subtracted always from 65536. You will get some value which is decimal, but I want the hex number because I have to load in TL and TH register in the programming. So convert the corresponding decimal into the hexadecimal. That's it. Yes? Any doubt? लक्षात येतंय का काय करतोय आपण ते? सिंपल आणि इंटरेस्टिंग कॅल्क्युलेशन आहे जर तुम्ही व्यवस्थित लक्ष दिलं तर. आणि एक दोन कॅल्क्युलेशन जर तुम्ही स्वतः केले तर तुम्हाला फॉर्म्युला पण लक्षात राहून जाईल. पाठ करायची गरज नाही. आणि तुम्हाला एक्झाम मध्ये काय विचारतात? राईट अ प्रोग्राम टू जनरेट अ डिले ऑफ 5 मिलीसेकंड. मग त्या केसमध्ये तुम्हाला कॅल्क्युलेशन्स करायचे आहेत. कॅल्क्युलेशन केल्यानंतर कुठला टायमर वापरायचा आहे, कुठला मोड वापरायचा आहे, ते तुमचं तुम्ही ठरवून टी मॉडची व्हॅल्यू कॅल्क्युलेट करायची आहे. आणि मग तो लास्ट वीक मध्ये आपण जो हा प्रोग्राम बघितला वरती, तो प्रोग्राम लिहायचा आहे. म्हणजे फक्त काय चेंज होईल, त्या डिले जनरेशन प्रमाणे जी काय व्हॅल्यू येईल टीएल आणि टीएच मध्ये ती लोड करायची आहे. दिलेल्या टास्क नुसार टी मॉडची व्हॅल्यू लोड करायची आणि बाकी तर सगळं सेमच राहणार आहे. त्याच्यामुळे इंटरेस्टिंग आहे, खूप अवघड नाहीये. तुम्हाला आत्ता अवघड वाटत असेल पण थोडीशी प्रॅक्टिस करा. मी तुम्हाला जे मस्जिदी बुक दिले त्याच्यात तेच मी आता ओपन केलंय. तर त्याचे काहीतरी 300 पेज पासून टायमरचं स्टार्ट झालंय. ते एकदा वाचा. इथे 328 पेज आहे पण 300 पासून स्टार्ट आहे बेसिक. ते एकदा वाचा. नाही कळलं तर नेक्स्ट लेक्चर मध्ये विचारा. आणि नेक्स्ट लेक्चर मध्ये शुअर आता कॅल्क्युलेशन्स पण झाले तर नेक्स्ट लेक्चर मध्ये मी तुम्हाला हे करेन, सिम्युलेशन दाखवणार आहे. आता तुम्हाला टास्क काय आहे, पहिल्या ह्याच्यात FF1A या व्हॅल्यू साठी किती डिले जनरेट होणार आहे तो कॅल्क्युलेट करायचा. आणि 10 मिलीसेकंद साठी 10 मिलीसेकंद डिले जनरेशन साठी काय व्हॅल्यू टीएल आणि टीएच मध्ये लोड करायला लागेल ते सांगायचं. हे 2 टास्क नेक्स्ट लेक्चरला करायचे. नेक्स्ट लेक्चरला मी विचारणार. ठीक आहे. आता कोणाला काही डाऊट आहे याच्यात असेल तर विचारा. अदरवाइज यू कॅन लीव द मीटिंग. कोणाला काही डाऊट असेल तर विचारा, टेक्स्ट करा, पण कन्फ्युजन ठेवू नका. ठीक आहे. Okay, then we'll stop today.
Thank you, ma'am.